So welcome back, Level 2 NCEA Chemists. Today we're looking at the last of the hydrocarbons, the alkynes. So the alkynes have the general formula of CnH2n-2, where N is the number of carbons, and the unique functional group for the homologous series is the carbon-carbon triple bond. And if you see a molecule which has this carbon-carbon triple bond, then the suffix is going to be the -ine, Y-N-E. So in terms of naming the alkynes, you can't have methane because you need at least two carbons to have that triple bond. So the first alkyne is ethyne. It has two carbons. Then we have propyne, butyne, pentyne, hexyne, and heptyne. So the prefixes are the same as for the associated alkanes and alkenes. So in terms of naming branched alkynes, or naming alkynes in general, you select the longest chain of carbon atoms containing the triple bond and number the chain from this end. Okay, so basically the smallest number has to go to the first carbon which is attached to that triple bond. Then you place the ending -ine on the basic name, and then use a number to indicate the lowest number carbon which has that triple bond. Okay, and as with alkanes and alkenes, then you have the prefix will be the substituents, and then the side chain position is essentially based on the number allocated from the first carbon with that triple bond. Okay, so looking at the first example, the longest chain is going to be 1, 2, 3, 4, 5. Okay, and the triple bond, so therefore it's pentyne. Okay, and the carbon with the triple bond is the first one, so it will be pent-1-ine, and then the methyl group is going to be therefore on the 1, 2, 3, 4th carbon, so it will be 4-methyl-pent-1-ine. The second example, again, you've got 1, 2, 3, 4, 5 carbons in the longest chain. So again, it's a pentyne. But this time, and again, the carbon with the triple bond is the first one. So it'll be pent-1-ine. But this time, the methyl substituent is on the 1, 2, 3rd carbon. So it'll be 3-methyl-pent-1-ine. And the last example, the longest chain is 1, 2, 3, 4, 5 again, so pent-ine, but this time, instead of being on the first carbon, the triple bond is on the second carbon, so it'll be pent-2-ine. That means that the methyl substituent is going to be on the 1, 2, 3, 4th, so it'll be 4-methyl-pent-2-ine. Okay, that's how you name alkynes. So just kind of reinforcing that, in terms of structural isomerism in the alkynes. So you get different structures based on different positions of a triple bond, but also branching from different substituents. So again, using our naming system, going from top right. So our naming system will be the longest chain will be 1, 2, 3, 4, 5, 6. So hex-ine, and the triple bond is on the second carbon, so the first one will be hex-2-ine. Going down, again it has 6 carbons, so it's hexyne again, but this time it's on the third carbon, so it's going to be a structural isomer of hex-3-ine. And then the final example on the left, the longest chain is 1, 2, 3, 4, so butyne. It is on the triple bond's on the first carbon, so but-1-ine, and the substituents therefore are on the 1, 2, 3. Okay, and there's two of them, two methyl groups, so it's dimethyl but-1-ine, but to be consistent, to make sure you know where those two dimethyls are, you have to put 3,3 dimethyl but-1-ine, because they are both on the third carbon. And that's how you name alkynes.